Hi, my name is Niall, and I'm going to do a short presentation on Ohm's law. So a brief overview is that I'm going to do the historical background of Ohm's law, its mathematical representation, the application of Ohm's law in theory, and show you a few examples, and its real-life applications. So, Ohm's law was formulated by a German physicist and mathematician called George Simon Ohm, who laid one of the foundations of electrical circuits relating the interactions between voltage, current, and resistance. This is him right here. He published his findings in 1827, which formally became Ohm's law. So what is Ohm's law, you may ask? So Ohm's law is defined as the relationship between current, voltage, and resistance in an electrical circuit. Note that this law only holds value when temperature is constant. When it is mathematically represented, voltage is directly proportional to current and resistance, V equals IR. The equation can be manipulated in three different ways, either to find voltage, current, and resistance. You make either the subject. Voltage is measured in volts, current is measured in milliamps or amps, and resistance is measured in ohms. Example of Ohm's law in circuit design. Let's say you try to find the voltage. Determine the voltage required to power a circuit that has 4.5 amps current flowing through a 50 ohms resistor. V equals IR. Use that equation. 4.5 amps of 50 ohms. Therefore, voltage is equal to 225 volts. Finding the currents. Let's say you have an 18-volt battery is connected to a 100 ohms resistor. What is current flowing through the circuit? Use current is equal to voltage divided by resistance. 18 volts divided by 100 ohms. Therefore, current is equal to 0.18 amps or 180 milliamps. It's that simple. Lastly, if you try and find resistance, if a voltage across a resistor is 15 volts and the current is 55 amps, what is the resistance of the resistor? Use resistance is equal to voltage over current. Therefore, 15 volts divided by 5 amps, the resistance is equal to 3 ohms. Lastly, the application of Ohm's law in the real world. These are just a few of the many examples of Ohm's law. When engineers design any electrical systems, from phone chargers to power grids, they use Ohm's law to make sure voltages, currents, and resistance are balanced safely. Secondly, sizing resistance in electronics. Every electronic device, TV, radio, and smartphone has resistors to limit current and protect components. Ohm's law helps calculate the resistor value to use so circuits don't overheat or burn out. Home wiring and safety. Electricians use Ohm's law to check if a wire resistance is too high, ensure appliances don't exceed circuit limits, and diagnose problems such as fault wiring or short circuits. Lastly, in medical fields, this is very important as they need precise currents flowing through ECGs or defibrillators, which make sure that they can save lives. Thanks for listening.